So we have this dy dx plus y squared sine of x equals to 0. We're going to separate these, and we're going to do this step by step so that you can really see what's going on here. The first thing I'm going to do is move our y squared sine x to the other side, and then multiply both sides by d of x. And it's going to look something like this. dy is equal to negative y squared sine of x dx. Now we want to separate this even further, so we're going to move the y squared to the other side. We'll get a y raised to negative 2, or 1 over y squared times our dy, and this is going to be equal to a negative sine x dx. Now what we can do here is integrate. When integrating, on the left-hand side, we are going to get a negative y negative 1, and this can be also written as 1 over y, which I'll do that right now. Negative 1 over y is going to be equal to, now we have a negative out front, and the integral of sine of x is just going to be a negative cosine of x. And that's pretty much it. We'll have a plus c since we don't have any min or max. And now what we want to do is just solve for our y, putting it in the best form that we can. Our y is basically just going to flip everything, and we'll move a negative to the other side. So we'll have y is equal to 1 over a negative cosine of x minus c, or we can get rid of all of this and put the negative out front and just say 1 over cosine x plus c. And this is equal to our y. So that's how I would look at this first one. And what about this next one, part B? For part B, we're going to do the same exact thing. I'm going to go a little bit faster on this one. So I'm going to do it in one fatal swoop. We're going to multiply both sides by y. So we'll get a y dy, and this is going to be equal to x squared over 1 plus x cubed, and then we have our dx here. Now we need to integrate both sides. So we're going to simply have a y squared over 2, and this is equal to, now you might notice a little bit or a lot on this side. So what we need to do is take this and set it equal to u. So u is going to be equal to 1 plus x cubed. I just realized I should have probably done a different color, but this one is sparkles, so we're going to go with it. Du is equal to 3x squared. Yes, that is a u. And then we have dx like this. And then we can substitute this further. Du over 3 is equal to x squared dx. And that is going to substitute in for all of this right here. So I'm going to rewrite this. We haven't taken the integral of it yet, so we'll have the integral sign still out here. We're going to have 1 over u, because that's what we substituted, and then we are going to have our being multiplied by du over 3. Now we can integrate. Remember though, it's important, and I'll leave a little bullet point over here, that the integral of 1 over u is equal to ln with absolute values of our u. So just keep that in mind. We're going to have y squared is equal to, I'll multiply both sides by 2. I'll bring the 3 out front, so we'll have 2 over 3. And then we're going to multiply this by ln. Our u, we'll replace it back in with 1 plus x cubed. That's what we substituted out to be. Since we have no min or max, we have a plus c. And we need to just get y by itself. So we'll take the square root of both sides. And we're going to be left with the square root of 2 over 3 times ln 1 plus x cubed, and then plus c. So that's going to be the answer to our problem. That's how we would solve the following differential equations. They're separable.